This video on the Matrox Repixel FPGA development kit covers the basics of Vivado IP Integrator and how to design custom firmware. We will create a new Vivado project and a simple block design in IP Integrator. We'll learn about the basic FDK building blocks and then generate a new firmware file in Vivado. Before we can create a new Vivado project, we need a new empty folder. I'm going to call this one FDK test. This will hold our new project. Next, run Vivado and find the tickle console near the bottom of the window. First, we set the current directory to the new folder using the cd command. Next, we need to run a script to create the project. So we type the following command. It will take a few seconds to create the Vivado project, and when it's finished, it will open the block design. This is the basic block design open now in IP Integrator. When you work with the block design, usually you want to make it bigger so we can zoom the window. We can even zoom closer to any particular block if we wish. This button is useful, it's zoomed to fit. The most important block in any design is the Central Control Unit, or CCU. This contains all the logic for the basic operation of the frame grabber. Here we also have a DMA read and a DMA write unit. These transfer units are responsible for reading image buffers from memory and writing result buffers back to memory. If you double-click on the CCU block, you'll see that it's configurable. You could change the number of interrupt ports, the clock frequency, and many other parameters. Most IP can be customized. DMA read, for example, can use different stream widths to transfer different amounts of data on every clock cycle, from 64 bits up to 256 bits every clock cycle. Same for DMA write. This design is complete. All the connections are made, but we could delete some just to practice drawing them. I removed the axis stream connection between DMA read and write. To put it back, I simply move my mouse till it becomes a pencil shape. Then I drag the line to the destination port. If I click on the clock network, you'll see it connects to every block. If I delete that, I have to put them all back. I could do it one at a time by dragging from the CCU clock to each block in turn, or I can do it more efficiently by right-clicking, selecting Start Connection Mode, and then quickly I can just click once on each destination clock and then press Escape when I've finished. When the block design is complete, move to the Address Editor tab and specify an address offset for each memory mapped slave port. In this case, everything is already set, so we'll cover the address editor in detail when we make a more complex design. When a design is complete, save the project if you haven't already, and then press Generate Block Design. This will create various files required for Vivado synthesis and implementation. It will take a few minutes to complete this step. Just take the default values, press generate. Once the generation is underway, you can see the progress from the Design Runs tab. Here's Design Runs. You can see that synthesis and implementation have not started yet, but the generation is currently running. The next steps are to run synthesis and implementation. But before that, let's check the settings from the Tools menu. The implementation settings are the most important. Sometimes you need to change these to make sure the design meets timing. They can also be used to improve compile time and make things run faster. The default settings are usually okay, but you could, for example, change the implementation strategy here. The default is Performance Explorer, which does some optimization. You could set even higher optimization, such as extra timing opt, if necessary. Let's leave it at Performance Explorer for now. If we scroll down in the implementation settings, we see that power optimization is currently enabled. We can disable power optimization if we want to speed up compile time. It will not increase power consumption very much, but it should reduce compile time significantly. So we'll do that and we'll apply. Say OK. The final stage after implementation is generate bitstream, which will create the actual firmware file. In fact, we can click generate bitstream right now, and it will automatically launch synthesis and implementation. Just take the default values. Now from the Design Runs tab, we can see that synthesis and implementation are queued. They will start executing as soon as the block design generation is finished. And finally, the generate bitstream will run. This is a long process. It could take up to an hour for a simple design, depending on the speed of your computer. Once the bitstream is generated, you will be asked whether you want to open the design. This allows you to see detailed reports on timing and resource usage, but we'll cover that in another video. So for now, let's cancel Open Design. In the summary at the bottom, you can see on this computer it took almost 2 hours, actually more than 2 hours, to do synthesis and implementation. On a fast computer, it's probably twice as fast as that. We can also see that timing was met successfully because the WNS value, worst case negative slack, is a positive number and shown in black. If this number is shown in red and is a negative number, then you have a timing problem. So now all that remains is to find the firmware file and copy it to the correct MIL folder so we can update the Repixel board with the new firmware. To find the firmware file, start in your Vivado project folder, FDK test. Then look in Runs, Implementation 1, and find the .firmware file. Here it is. You can now copy this file to the correct MIL folder and update the Repixel board with the new firmware. The MIL folder is Program Files, Matrox Imaging, Drivers, Repixel CXP or CL if you have the camera link version, and finally Firmware. These are the various Repixel CXP firmware files. The CXP Pro uses this file. Now we could copy our custom firmware to the mill folder, but we'll have a name conflict. To avoid that, you either delete the original firmware or you can rename your custom firmware to start with the letters FDK. Now you can copy the file without a name conflict. And the mill firmware updater will give priority to your file because it begins with the letters FDK. To start the update process, you just have to run any mill application. If you actually generated a firmware file and have a Repixo Pro board in your computer, you can now load the new firmware onto the board and test it. For example, you could run Repixo Bench. If you only have an evaluation version of the FDK, you won't be able to generate a firmware file, so you will have to skip this step. For more information on the topics covered in this video, please see the Repixo FDK user guide. For a more complicated example of custom firmware with processing units written in Vivado HLS, we suggest you watch the video on the HLS design flow.